Alrighty, so we're just basically gonna go through the questions, and your guys' thoughts. So remember it was, what do you like about the work? All of that. So would you guys rather have this on the board, or would you rather have the students' work on in order to talk? Okay, the students' work. Remember, democracy is a good thing. Alright, so the conjecture, what were we trying to prove? What was our goal? Or what was the student's goal in that, like, at the beginning of the problem?
Prove or disprove this?
Yeah, so they wanted to prove or disprove that if you draw two diagonals of a quadrilateral, you divide it into four equal areas. So their thought process was, okay, I'm gonna use a kite, and so they got the answer, the kite is not true, so therefore this whole conjecture is not true. So the first question was, what do you like about the students' specific work?
Yeah, I really like that they have the actual picture and you could actually clearly see what they were doing to get their answer.
Yeah, so would you say they like calculated their areas correctly of the triangle?
Yeah.
So they're answering their own question correctly.
They did what when doing these calculations. You could follow it well. Like the last line, 4 versus 12.
So has the student made any assumptions? Or, what do you guys think about that? Did they make any assumptions?
That the kite does not work for this statement.
That,
Like,
Do you mean
do you mean during or like at the 5 minute?
just throughout the whole thing, so
Okay.
I think what you might have meant to say is they assumed that a kite would prove or disprove this.
Yeah.
So they thought that this one example of one of the many quadrilaterals would prove or disprove it. Okay, so they assumed that. Did they assume anything else?
I mean, my concern kind of goes in this question as well as the other one about accuracy. Improving them. They seem to assume that they didn't need to draw things to scale.
Okay.
Because like that 2 looks almost exactly the same as the 4. So they're kind of assuming that won't matter. But I think
So is the work that they did specifically though, is that accurate? Moving on to the next question.
parts of it. They use the area. Like assuming they're 2, 4, 60.
Yeah. So they have the correct areas.
Yeah.
So it's definitely not true that the 4 areas
With those, like assuming those labels like they did.
Yeah. Okay. And so what would you guys do to this explanation to prove it in order to prove the top? To say like always, sometimes, or never true. That's always the end goal, is like, always, sometimes.
Just show an example about one.
And that would give us a sometimes. Yeah.
But I think that it's never. I don't think it's like
Yeah.
with their, because 6 plus 2 is 8, and then 4 plus 4, and assuming they're trying to draw this.
Yeah.
So then they actually, like with those measurements, maybe have a square.
Yeah. So what if you were to draw a kite? What would,
So I think they need that, like that 2.
like if this was a kite, what would you want to use in order to?
Yeah, like for that one, I would do something like 2, 8, 3.
Okay. So you think this would give a better representation of like kind of what's going on?
Because the way that they're kind of drawing the kite like that.
Is the same as like 2, 6, or for, yeah, like they could be, but
Yeah.
I understand what you're saying.
Right, like if you're gonna draw a kite that really emphasizes like the bottom triangle
Yeah.
longer or taller than the top, then you can't have equal length diagonals.
Definitely. Yeah.
So I think it makes it makes you suspect of their argument because the length is so off.
It is interesting how, I say this in a good way, that like you're so caught up on the label, like the
Yeah.
picture, cause I would have never been so adamant about it, you know, so.
Yeah,
I
but
like
it makes me suspect. I don't think they actually. I think a quadrilateral that had their labels, like two, well, like a diagonal of 8 and then a diagonal of 8. I think it's important. Like I think maybe if there are two equal length diagonals, I'm not sure you can. But like I'm not thinking.
Yeah. No, it's cool that you were able to take that away. Okay, so they said never true, but so we kind of came to the conclusion that it is sometimes true. What about our second guy or girl?
I was really hard to follow and like to see if their explanation was correct because you didn't really know what they were doing. So like I didn't know if they were actually using the midpoints of the lines. I assumed it, but since they don't say it, you can't really be sure.
Yeah. Yeah, this one is kind of all over the place. Lots of tick marks. So what did they, that being said though, what did they do well, do you guys think?
I think you're going for ironically, you probably go more so on the like half
Yeah, it's interesting that they were able to make the connection that the middle, the connection of the two midpoints in the middle is equal to what's on the side, which is interesting. So like, since this is a parallelogram, or they were trying to draw a parallelogram, it was interesting that they made the connection that this is equal to this. You know what I'm saying? I wouldn't have immediately saw that, or like, no, that wasn't necessarily true. So what else do you guys think? What do you think did they make any assumptions? Like is the word wrong necessarily? Like their particulars?
I did assume that the diagonal would intersect the same point as the midpoint. I don't know if they know that or if they just try to draw a picture accurately and just like, oh, it's good enough for this picture.
Do you have any thoughts about accuracy? So to kind of close out this one, how could this explanation specifically be better than what they did? Because their final answer was always true, and in the question before, we decided, well, it's not always true. So a parallelogram wouldn't be. So we kind of get to see two ends of the spectrum. We see a student only providing a counterexample and not really thinking about what would work, and then a student only providing an example that would work and not really think about a counterexample. So in your guys' as like future teacher and future teacher, like do you guys think, not that one is better, but like which student would you rather convince that they're like not necessarily correct, that their explanation isn't enough, assuming all their work is correct?
I would pair them off with each other and have them both explain why they're both kind of right.
I'd be interested if they would be like willing to conform or just
Yeah.
get frustrated.
I mean, I think from just like repetitions, like the difference between sometimes and never, like they don't care. Like for them it's either it's all or it's not at all.
Yeah.
Like always true or not always true. So I think they would be.
That's interesting. Because it kind of seems like the second student is more like, is kind of making more mathematical connections than like, you know what I'm saying? Like,
Yeah.
the first guy just draws a kite, does the area.
Mm-hmm.
It seems like the second one might know more.
But as far as like what
Yeah.
concerned, they would think that it was true parallel or it was true line.
Okay, so to finish out, so they would have had the lesson end after this discussion, so that would have been our summarize. Basically, our summary is we can't just like provide a counterexample and say never, and we can't always just provide an example that works and say always, but there's more to it than just that.
So that's why it was